Hello and welcome to this screencast, which is going to cover how Java ME Embedded can be used with the Raspberry Pi. My name is Simon Ritter and I work for Oracle as a Java Technology Evangelist. What we'll do today is to give you some ideas about how these two things can be used together to create some really interesting types of applications. Let's start with a quick recap of what the Raspberry Pi actually is. It's a small and cheap but very powerful single board computer. At the heart of the machine is an ARM11 processor running at 700 MHz. This is put together with the memory in a single on-chip package. Thanks to the work that's been done by the Raspberry Pi Foundation, you can now overclock the processor up to 1 GHz without breaking the warranty. I typically run mine at 900 MHz and I've not had any problems at all in terms of stability of the board or applications. Originally shipping with 256 megabytes of memory, the new boards now have 512 megabytes, so there's plenty of room for application code. From an I/O perspective, you can connect the board to a monitor or a TV screen using either the HDMI or a composite video output. There are some USB ports, so you can connect a keyboard or a mouse, and there's an Ethernet connector so that you can connect it to the network and log in remotely using things like SSH. One of the exciting things about this particular board is the fact that it's got a number of header pins available. These give you the ability to work with general purpose I/O, a UART for serial communication, and then SPI and I2C if you want to connect more complex peripherals. Java technology covers a very wide range of devices, from the very, very small all the way up to the very, very big. Looking at embedded types of applications, at the very low end you've got devices or things like a Java card, which have literally tens of kilobytes of memory. For bigger devices which have more than 10 megabytes of memory, maybe even hundreds of megabytes of memory, you can actually run Java SE Embedded, which is a full implementation of Java SE. In fact, for the Raspberry Pi, we recently released an early access version of JDK 8 for embedded, because the Raspberry Pi has enough memory to do that. What we want to do though is to enable people to use Java ME on this device. Java ME fits in the kind of memory space where you've got somewhere between 1 and 10 megabytes of memory. The idea behind making Java ME available on the Raspberry Pi was because it's a very cheap and easily available board. It allows people to test and develop applications before deploying them onto a more commercial type of board. If we look at Java ME Embedded version 3.3, there are a number of key features that we have there. At the bottom of the stack, if you like, is the connected limited device configuration. And what this does is provide the definition of the Java virtual machine and a small set of APIs which allow the very basic form of applications to run on top of it. This is defined through the Java community process and specifically from JSR 139. On top of that, we then have a profile. And when Java ME was first created, there was the idea of configurations and profiles. Configurations were tailored to a broad range of devices which had a particular range of memory, and then the profiles were tailored to specific types of devices in terms of their capabilities. For embedded devices, we use the information module profile next generation. In addition to those, we also have some other APIs. So there's things like the ability to do file input and output, there's some web services capabilities that you can use, there's some additional security and trust services, and you can even do things like XML processing from within Java ME. Looking at Java ME Embedded and the Raspberry Pi specifically, as I said, we're using the IMP next generation APIs. And this is really based on MIDP 2.0. If you've done any programming of Java ME with mobile phones in the past, then you'll be familiar with how this works. We use the same kind of ideas for the lifecycle management and the way that we deploy applications onto the device and so on. One of the things that we were left out from the specification because we didn't feel it was relevant to this type of application was the LCD UI and the game APIs. terms of executing the code, you use a thing called an emulator, which uses the same lifecycle methods as midlets. You have the ability to start an application, so you can set up what you want to do when it starts. There's the ability to handle things when the application pauses, and then there's also the capability to handle what the application does when it is destroyed and finishes. All of this runs in less than 4 megabytes of runtime on the Raspberry Pi. In addition to the standard APIs that I mentioned in the last slide, we've also included a thing called the Device Access API. I mentioned the idea of the Raspberry Pi having all these header pins that we'd like to be able to use. And what the Device Access API does is give us a nice clean way of accessing all of these connections externally and enable us to write simple code to make use of them. One thing that you do need to be aware of is that some of the devices that you talk to do require root access, although as we're talking about this in terms of an embedded system, then it's not really too much of an issue from a security perspective. To use the Device Access API, we need to ensure that the emulator that we're going to run has the right permission to access the underlying hardware and the relevant parts of the Java ME runtime. This can be done in one of two ways. The first, which is a little bit more complicated but also more flexible, is to have the emulator be digitally signed so that it's trusted and can be granted the relevant access to the things that we need. To do that, you need a certificate authority, you then need to sign the emulator itself, and there's instructions on how to do that in the Getting Started guide. The second way to do it is to allow any untrusted emulator to access the devices on the Raspberry Pi. This is fine if you're doing development testing because you're not working in a deployed application, so you understand what's going on. So from a development testing point of view, what you need to do is change the policy.txt file in the appdb directory of the Java ME home installation. All you need to do there is to look in the file and you'll find that there are two domains which have information about what untrusted and unsecured emulets can do. So there are two domains specifically that need to be edited. One is the untrusted and unsecured one, and the other is the minimum and unsecured one. And all you need to do is add the allow::device access to these two domains, and then your emulator will be able to access the pins without any problem. From a coding point of view, what I've got here is a simple example of how you can configure a pin to be accessed from within your code. Now you can do this again one of two ways. This is the slightly more complex but also more flexible way, where we define a GPIO pin config object in order to use the peripheral manager to open that particular pin. So we create a new GPIO pin config object, and we pass in a number of parameters to the constructor. First of those is the port number. What this does is it allows us to group together a certain number of pins, but we're not doing that in this case, so we just treat that as 0. Then we have the specific pin that we're interested in. This is pin 7, and if you look at the Raspberry Pi documentation, you'll be able to see which pins are available on the header. After that, you've got the direction that you want the pin to work in, so we're going to use it as an output pin. You can also configure it as an input pin or as an input and an output pin. There's some configuration of the mode, which we're just going to use the default. If you want to see more information about that, look in the documentation. There's some quite complicated things that you can set there. And then if you're using the pin as an input, there's different ways of having it trigger. Again, if you look at the documentation on that, you'll see the different ways that we can do that. And lastly, we've got the way that how we want to set the pin when it's first made available. So we're going to set it to be false, which means it's low. In order to get access to the pin using that configuration, we use the peripheral manager and we call the open method with that configuration that we've created. That will return us a pin in the form of a GPIO pin object, and then we can use methods on that to control it. So here I've got a simple method, set value. We're going to set it to high or true, and obviously we could set it to false, which would set it to be low. So having seen all that, let's move on and see a demo of how this actually works in practice. So in this part of the demonstration, what I'm going to do is I'm going to show you how we're going to configure an emulator so that we can test our Raspberry Pi code before we actually deploy it. Now here I've got the code that we're going to use. So we've got the emulator, which is extending midlet here, and what we do is we use the same GPIO pin configuration that we talked about earlier. We've got 2 of those, and then we simply say, okay, give me the user peripheral manager to open the ports, and then we're just going to loop 3 times, moving the motor one direction and then the other direction, so clockwise and then anti-clockwise, 1 second each. Now, in order to do that, we need to create an emulator. So what we're going to do here is use part of the Java ME SDK, which is the custom device editor. So if I click on that, we have CDC, CLDC, and IMP-NG. And what we want is an IMP-NG. So we click on New for that, and that brings up the screen that allows us to configure that. And what I'm going to do is I'm going to call this Raspberry Motor, and then what we need to do is we need to add 2 pins. So add a pin, and in this case we're going to call this one pin 7. Hardware port number we'll leave as 0 because that's what we've used, and pin number 7. Direction is going to be output, trigger none, and that's okay. Then we add another pin. In this case we'll call it pin 8. Again, that's already filled in for us, but we need to change direction to output, and that's all we need. So we've got the name of it, we've got 2 pins configured for GPIO. If we wanted to configure anything else like I2C, SPIO, and so on, we could do that as well. But from the point of view of this application, we're just using GPIO. So we've done that, so click on OK, and now what that's going to do is creates us Raspberry Motor. And then what we'll see in NetBeans, we go back to there, is that we should, well, there we go, the device is now registered, and so we now see that there's a Raspberry Motor down here in the device part of the display. And what I'm going to do now is say, okay, for the Raspberry Motor application, I need to go to the properties of that, and then I click on platform, and here we've got the device that we're going to use, and in this case it's actually IMP-NG device 1. I'm going to change that to be the Raspberry Motor device that we just created. Click on OK, and then if I run this application, what's going to happen is it will start up the emulator, and we should see the emulator in a moment when it comes up. And if I switch to GPIO pins, you'll see that here we can see the status of that, and it's changing from high to low as the application runs. And then that's finished doing its 3 iterations, and if I close that, we come out of the bottom and the application has finished. For the next part of the demonstration, what we're going to do is show you how to configure the Raspberry Pi through NetBeans so that you can actually deploy the emulator from NetBeans directly to the Raspberry Pi board. So in order to do that, what we need to do is remotely log into the Raspberry Pi. So I've configured that with an SSH server, and I've logged in as one of the users onto the actual device. So if I ls here, what we've got is Java ME 3.3. If I go into that directory, we'll see that there is an appdb directory, which is where the policy file is that we need to change. There's the bin directory and the lib directory. And if I go into the bin directory, we'll find that there's a number of scripts here that allow you to do things like install midlets, list binlets, and so on. What we're going to do here is actually run user test. Actually, no, what we're going to do is we're going to su first, because you need to run it as root. And once we're logged in as root, what we're going to do is run user test, which will enable us to deploy directly onto the Raspberry Pi. So that prints out a few messages so we can see that it's actually up and running, everything seems okay. Now if we go back to NetBeans, what we'll see here is that we've got the window which shows us all the devices that we have, and that's where we created our Raspberry Motor. And what we're going to do now is we're going to create another new device. This time we're going to give it an IP address. So if I type in the IP address of our Raspberry Pi, then what's going to happen is it's going to say, oh, yep, that's okay, so that's done. And if I click on finish, what will happen is that that will appear as an external device, and at some point hopefully we'll see that the device will be registered, which it seems to be. Okay, So now if I go back to my Raspberry Pi project, I open up the properties again. If I go back to platform, if you remember, this is where we set the device to be the Raspberry Pi motor so that we can use the emulator to see our application running. Now we've got the external device, which is the real physical Raspberry Pi. If I select that and then click on OK, it's all ready to go. Now if I run this application, what I'll be able to do is I'll be able to see that the output from, hopefully, if I come down here, the putty that's downloaded it, and now we've got the application running. If I can get onto there, we'll see that what's actually happening is we're getting information back about the fact that it's set the motor pins, and we'll see that it's printing out the iterations. And what we can then do is see that running in real life. Here we have the hardware setup that we're going to use for our demonstration. We have our Raspberry Pi, which is connected to the network so that we can access it through SSH. We've got an SD card, which is configured with the Raspbian distribution and has booted off that, and then we've got the Java ME Embedded 3.3 installed and running on there. What we've then done is to connect some of the GPIO pins that are available on the board. So we've got a plus 5 volt line, we've got ground, and then we've got pins 7 and 8 connected. These are fed to this little circuit board here, which contains a chip which is acting as an H-bridge. And what the H-bridge allows us to do is to control different voltages and significantly higher currents than we can do directly from the GPIO pins. So we feed the outputs from the GPIO pins into one side of the H-bridge. The other side of the H-bridge uses a plus 9 volt power supply here and can control a Lego motor. So the outputs come through to here, we feed the outputs to the Lego motor, and then from the Raspberry Pi we're able to control the Lego motor. And if we run the application, what we'll find is we should get the motor moves. There we go. Now that we've seen Java ME Embedded running on the Raspberry Pi and controlling some of the GPIO pins, what should you do next? Well, the first thing is, if you haven't already got a Raspberry Pi, go out and buy one. They're cheap. Next, you need to download the Java ME Embedded Runtime and the SDK. You can do that from the address that's shown here. Once you've got that, you can install it on your Raspberry Pi. You can integrate the Java ME Embedded SDK with your favourite IDE, whether it's NetBeans or Eclipse, and then you can start building some Java applications of your own. Thank you for listening to this screencast on Java ME Embedded 3.3 and the Raspberry Pi. We hope you enjoyed it.